the angle OBE to be 20 degrees and the angle DBC to be 42 degrees. We're told that this line here is a tangent to the circle at B. O is the center of the circle. And if O is the center of the circle, there are some lines we can identify. We can realize that from O to P must be a, what kind of line would O be? It must be a radius. It's gone from the center to the circumference. So we know that OB must be a radius. And OE is also another radius. And because OE and OB represents radius, what can it say about triangle OEB? If both OE and OB represent radius, what does it mean for triangle OEB? No. We wouldn't be able to say that. Triangle, man. Triangle. What can it say about triangle? We can't say triangle is supplementary. Triangle, what are the types of triangle we know? It means that it is a isosceles triangle. And if it's an isosceles triangle, what do we know about the angles in an isosceles triangle? Which ones are equal? The ones at the base. So we know the base angles are going to be what? So if this angle here is 20, this one here must also be 20. Are we following that? So without even thinking about it, I could fill in 20 right here. Because I know that that angle must also be 20. Because if a triangle is formed by two radii, that triangle automatically is isosceles. And in an isosceles triangle, the base angles must be equal. Let's go to the question. It wants us to find an angle that goes from B to O to E. So we are turning from B to O to E, which is right here. How then do we find that angle? Any suggestions? How do we find the angle that goes from? I'm not hearing. Add up which two? So we're going to add the two angles in the triangle we know and subtract from 180. So this is going to be 180 minus 20 plus 20, which is going to be 140 degrees. And we can say that base angles in an isosceles, and I'm abbreviating the word isosceles, triangle are equal.
Base angles in an isosceles triangle.
And I could also state sum of interior angles in a triangle add up to 180 degrees. So I have found angle BOE. Using the fact that two radii meet a chord, that triangle will be an isosceles triangle. Let's now take a look at part 2 of the question. Angle that goes from O to E to D. We're now looking at the angle that now goes from O to E to D. The angle that goes from O to E to D, which is this little piece right here. We want to find that angle right there. The angle going from O to E to D. We can now fill in this angle right here. We now know this angle is 140. Now if I want to find the angle that goes from O to E to D, I must look at it and see what relationship I already know.
They both touch the center from the center.
But that's not a relationship that we can use because there's no theorem that speaks to that. However, if you take a look at this angle right here, This angle here is between a chord and a tangent. What do we know about the angle between a chord and a tangent?
Is that this equal to the angle in the alternate?
The angle in the alternate segment. How do I know which angle is in the alternate segment? We must look for the angle that sits on the chord. Do we see that this angle of E here sits on the chord BB? So then, this entire angle here at E must be equal to 40. And if this piece is 20, I can find this piece to be 22. So I could now go ahead and say this is going to equal to 42 minus 20, which equals 22. And my reason for using 42 now be angle formed between a chord and a tangent is equal to angle in the alternate segment. So we must realize that this angle is 42, this entire angle must also be 42 because it's in the alternate segment. And remember, the angle in the alternate segment will always sit or stand on the chord. So it will be on the chord BD. I realize the angle here at E is angle DEE. It stands on the chord that forms the angle with the tangent. We want to now find our final piece, which is now angle BFE. So we want to look at the angle. I'm going to fill right here in as 22, so we can know that. The angle that now goes from B to F to E, which is right here. So let's take a look at this. What's this angle here? 140? Why do you say 140?
Sorry, go on, sir.
You sure it's going to be half? Are we sure about that? We have to be careful. Remember now, in order for it to be a half the one at the center, they must be in the same segment. Is this angle and this angle in the same segment? No. Because the chord PF divides the circle into two segments. This is one segment, this is the other. So they're not in the same segment, so we can't use that. However, can't we find this angle right here?
Yes, sir.
Isn't this angle now in the same segment as the one at O?
Yes.
So this angle would then be a half of 140, which would be what? 70. So this angle here would be 70. So let's first find the angle that goes from angle EDP equal 140 divided by 2, which is 70. And I can write angle at center is twice angle at circumference standing in the same segment. So in order to use the theorem, they must be standing in the same segment. Now that I know this angle here that touches the circumference at D, is there a relationship between the angle touching the circumference at D and the angle touching the circumference at F?
Opposite.
Opposite angles in a are supplementary in a what? In an alternate. How many points there? Cyclic. So then these are now opposite angles in a cyclic quadrilateral.
180 take away 70.
So then angle BFE is equal to 180 minus 70, which is 110 degrees. And our reason would now be opposite angles in a cyclic quadrilateral are supplementary. and we would have found all the angles asked for in our given circle. Alright, that's a wrap. Please take that.